Hello and good day to you guys. So today we are going to proceed with our final demonstration. So we are basically going to explore three types of analysis by using Revit. So the first analysis will be doing solar radiation analysis. So this analysis will be very great to see the amount of energy as well as heat reflected into your design. Secondly is the daylighting analysis. So this is to identify the luminance level of your space. And then thirdly is the shadow and sound path analysis. So all of these analyses are very easy to be conducted in Revit, provided that you have the design. You can basically conduct the analysis to your conceptual model or conceptual meshing. This is for the conceptual stage, or in your detail elements building. Okay, so this is in this case it is much more appropriate to us, where we have actually designed some kind of a detailed building or detailed elements into the project. Okay, so before we start, just to remind you guys, for those who haven't installed the Insight plugin, you are required to install that in order to run this analysis. Okay, so if you didn't install it, you won't have these settings into your in your Revit. So it's important that you go to Autodesk. It's the website that I've shared on the previous class, and download and install the plugins, the Insight plugins for your Revit version. Okay. All right, and apart from that, I also like to remind you that please ensure that your students' license, Autodesk student license, is also activated, because some of the analysis, for instance, the lighting analysis requires cloud rendering service. So it requires you have a cloud point in your registration. So if you have already applied for students license or educational license, you will get free credits, okay, credit coins to run this analysis. So please ensure that your students account or license is activated. And then, yeah, first thing first, we are going to explore on doing solar analysis. So there are several steps that you need to do before conducting all of this analysis. Yeah. So the first is you need to set the location of your building. So the setting of location is exactly the same like what I showed you guys last week. And then you will need to set up your rooms. Okay, because some other analysis, for instance, the lighting analysis requires information from the room. So you need to place all the room into your design in order to run the lighting analysis. And then also the sun settings. Okay, you will need to set the sun path settings into your design as well. So yeah, first thing first, perhaps we're going to set the sun settings. So you can go to here. I'm going to use multi-day. So for the location, I already set the location as per last week's model. And the date is, yeah, I can set it to, maybe the analysis can be run from January all the way to today's date, perhaps. Okay. So it's like almost an annual or an annual solar an annual reading lah for the solar radiation analysis. Okay, and then yeah, ground plane is at level 1, and then just click OK. So we have set the sun settings. Next is to check the location. Okay, so in this case, I already inserted the location. Okay, it's exactly the same like what I showed you guys during the energy analysis demonstration. So there's no need to repeat on that. And then I need to place all the rooms. So go to architecture, go to rooms, and simply place all the rooms into the design. And also ensure that that the area and computation is covered areas and volumes. Okay. Yeah. So I've set all the three settings. So now let's run the solar analysis, the solar radiation analysis. So you can just go to analyze and select solar, solar analysis. Okay, click this. Okay, you can view it in 2D view. Okay, so to perform solar analysis, it must be in 3D view. Even if you want to do a plan view analysis or plan a solar diagram using plan, you need to open it in your 3D view. So I'm going to show you later on how to actually set your camera to capture the plan view of your analysis. But first, we open up the 3D view, go to solar analysis. Okay, study type, you have solar energy annual PV to determine the annual PV on each of the surface. Okay, you can also have you can also choose to have custom. So in this case, I just select custom. These are the settings for the solar analysis. So the analysis period, like what I've shown you guys just now, I'm going to use the sun setting based on the timeline that I have applied just now. The rest I just ignore it. Okay, so the surfaces, there are several types. Okay? So let's say if you are using conceptual massing, if you are designing your building during the conceptual stage where there's no building elements, it's all mass, you may choose this. All roof exterior is only detecting the surface, the roof surfaces. Okay, and then if you want to have a more detail, you want to see how the energy, uh, the sun radiation radiates to all of the surfaces, you may use user selection. Okay, so once you use user selection, it will ask you to select the surfaces. Okay, so you can just point your cursor and select any surfaces that you want to include into your analysis. It can be the walls, it can be the floors. Okay, but you cannot select openings or windows, yeah, because yeah, Revit doesn't allow that. Okay, because it's not considered as a surface, because it's a transparent surface. It allows sun radiation to penetrate it, so technically it's not a surface lah. Okay, so I have selected all the surfaces, the roof, walls, and the floors. So just click finish here. Okay, next is okay. Notice that the area that's been selected is 860 meters square. All right. So for this first. Okay, now select type. I just maintain a cumulative installation. The unit, usually in Malaysia we just use kilowatt hour per meter square or British thermal unit per feet square. Okay, so I just use kilowatt per hour. You can always change later on. And then the styles, I just leave it as it is first. Okay, so right now I just want to run the analysis. So click update. So what Revit is going to do is going to start analyzing. So this is the reading that I get lah. Okay, custom solar is the right now the date is the date is not changed. It's quite weird. Never mind. You can just go to sun setting again and recheck. Oh, I don't know why it's overriding the previous date that I've set, but never mind. I can just reset it. So set it back to January 2020. Until today's date, perhaps. All right, and then just click OK. And we run the analysis. All right, so the date is slightly correct. So I don't know, it can be either way. So you may set the sun settings after when you are conducting the solar analysis itself. I'm not sure why it's overriding the sun setting that I have set previously. But anyway, when I change it and I rerun the analysis, I will get the same the date that I want. So it's not an issue at all. All right, so this is the legend. Okay. So notice that, of course, the roof is going to to absorb the highest amount of energy lah, at 1539. So you can see that the rest of the spaces, there are some energy reflected on the surfaces, but it's not intense as the roof lah. Okay, so let's say if you want to change the appearance of your analysis, you can always do that. Okay, you can just change any of this. Okay, so this is solar analysis annual 500 kilowatt per hour. So you see when you change to 500 kWh, you will get a more detailed breakdown of that particular analysis. Okay, the breakdown is much more detailed. The color is much more vibrant and very clear. Okay, this is 200. Not very clear because it's limit up to 200 kilowatt per hour per breakdown. So I would prefer 500 kilowatt analysis. So apart from that, you can also show in the form of points. Okay, so whichever that you prefer, actually, whichever that you prefer, you can show it clearly. You can choose it. If you want to change the styles of your analysis, there's this 3 dotted box next to it. Okay, just click this and you can change the styling of the analysis. So right now what I open up in this model is the solar analysis annual 500 kilowatt per hour. So let's say if I want to show grid lines, I want to show contour, I can just click apply. Okay, so you will see that when the grid line is applied, you can have a much more detailed breakdown of surfaces within the design. So you can able to see lah which surface is the most that absorb the highest intensity of sun radiation into the surface. All right, so that would be generally it for solar analysis. Let's say if you want to view this in your plan view, okay, there are some steps. You know, because some of you might want to show the diagram in the form of plans. So as what I said earlier, when you want to do solar radiation analysis, you cannot use 2D view. You must use 3D view. So in this case, you must set your camera to a plan view and you need to rerun the analysis. So I'm going to show you how to do it. So go to elevation, any elevations that you want. Okay, I'm going to select the north elevation. So go to this tab, camera, or you can go to view, go to, yeah, here, 3D view, camera. Click this. Make sure that the perspective is off. You don't want to have a perspective view for that plan view. So you just place your camera in between level 3 and level 2 and make sure that the camera is pointing downwards to the plan view. Click this and make sure the line is straight so that you can have a perpendicular view to the plan. Okay, click it. So this is the plan view, right? Okay. So if you want to reflect the analysis back, you will need to rerun the analysis. So in this case, go to analyze, go back to solar, select, you can click this to select the surface. Select the surface, click finish. Perhaps the style I just want to maintain to the one that I've the changes now, the solar analysis annual 500 kilowatt hour. Click this and update. Right. Yeah, so from this plan, you can basically see that the east orientation absorbs more energy. So perhaps you might want to, I don't know, perhaps place a PV panel at this area as well. Or because when you have a lot greater solar radiation, of course, you're going to have a lot of heat penetrating to the surface. So in this case, when I analyze this plan, I can see that the east orientation absorbs a lot of heat from the timeline from January all the way to November 2020. So I don't know, perhaps you might want to optimize by putting sun shading, or you want to apply a double skin layer, or a corridor facade or whatever, to limit the amount of heat to the space. So there are a lot of strategies that you can undertake in order to address this issue. Yeah, and if you can see, the second most prevalent solar radiation penetrated into the surface would be on the west as well. Okay, and then but the most intense will be on the east lah. So perhaps you might want to do something on that. Okay, another tip, if you want to relate your energy analysis with the sun path, you can do that actually. So it's very easy. So you just zoom out and turn on your sun path. Okay, so by having the sun path, you can basically relate lah the energy analysis with the actual sun path. So you can see this is the annual, so the time frame of the sun path between 1st to 11th of, sorry, between 1st of January 2020 to 1st of November 2020. So within this time frame, you will see that this within this sun, this path, this is basically the pathway of the sun. Okay? So you can able to see how the sun reacts with the building. All right. Yeah, that will be it for the solar radiation analysis. So after this, we're going to proceed with the lighting analysis. Thank you very much. Hello guys. Okay, now we are going to explore on doing daylighting analysis, or in this case, illuminance analysis. So we're going to identify the amount of illuminance recorded for this design. So please make sure, like I said in the earlier part of this video, you have set your location. If it's necessary for you to orientate your building according to the site, according to the sun path, you can also do that. Okay, I have shared a link on how to actually orientate your building according within your site. And then yeah, let's try and run the lighting analysis. It's very easy, but like I said, please also ensure that your student's license or your education license is activated, because you will need to use the free cloud credits in order to run this analysis. So please ensure that your educational license is activated when you want to run lighting analysis. Okay, so run the lighting analysis is go to analyze, and here it's under here. Run a lighting analysis in the cloud. So click this. All right, so we're going to start with a new analysis. Okay, in this case, I already done one analysis before this. So now man, just click run a new analysis and just go, click go. So this is the setting for the lighting analysis in the cloud. So you can basically do a lot of types of analysis: illuminance analysis, solar access analysis, daylighting factor. You can even cross or compare with LED requirements analysis. So it's up to you, but I'm just, for this demonstration, I'm just going to use illuminance analysis. Okay, and then levels, I want to identify all the levels. Okay, so I just click all. and then need to set the environment for the lighting analysis. So in this case, need to set the date and time. So click date and time. We're going to set it to how about the date, today's date? Yeah, so try today's date, 9 a.m. All the way to today's date. Sorry, today's date, 3 p.m. Okay, so just click OK. All right, and then the illuminance settings, I just maintain it. The threshold lower at 300, the upper is at 300. But the most important thing is the lux. Sorry, the unit value, whether you want foot candles or lux. So usually we use lux level to determine the illuminance level for the space. This is to set the height of the analysis plane, because the plane of the analysis must be above of the floor lah. So in this case, it's 32 inches above the floor. So I just maintain as it is. The resolution, whether you want to use 12-inch grid for the appearance of the analysis, or you want to use 72-inch. All right. So like I said, for this analysis, it requires you to use cloud credits. Okay, you will need to purchase these cloud credits for those who doesn't have any educational license. But like I said, applying for education license and Autodesk is free of charge, so there's no need to pay for it. Okay, so once you have an education license or a student's license, you will you don't need to use any cloud credit. It's all free of charge. So check price. So it required 0 credits because why? It's an educational license. So just click start analysis. Yeah, so the model will be uploaded to the cloud. So you need to give some time for the analysis to run and reflect back into your Revit. So it will notify you later on. So all you have to do is just wait for the analysis to be complete. Okay, also make sure that you save this project, okay? Because once you have conducted analysis, it's important that you save it so that you don't waste your cloud credits. So just click OK. So we shall wait for the analysis to complete. You can go to the lighting, and you can go back to the lighting analysis, and you can look at the status of the process by clicking down this. So notice that it's still in process. So once the job is complete, it's going to notify. Yeah, it's still in the process. So wait for the current daylight analysis to finish. All right, guys. So I've run the analysis, and it took me about 5 minutes, 5 to 6 minutes for the analysis to complete. So once the analysis have completed, you will get this notification. So the luminous analysis was submitted at this date, and it's complete for the project. So 0 credit required because cloud credits is based on educational license. So accept, update, and save the project. So it's going to update this model, and as well as to save the project into your desktop. All right. So once you have saved it, you can go to lighting and click on this to generate result. Okay, so these are the summary of the analysis. So not very important, but the thing is, I set the analysis at 1st of November at 9 a.m. Okay, so click this. All right, so it will display out the this how to say this illustration of how the light reacts within the space. So it generates on the ground as well as the first floor level. So if you want to look at the plan view of this, this is where you need to use section box. Okay, so you enable your section box, and you can somehow cut the top portion. Right, so now let's tilt this and align to the plan view. So you can drag this legend here. So at the time frame of 9 a.m., 1st of November, you can see that the light value or the luminance value in my building comes from the east as well as southern facade. So the value that I believe that have been gathered is around 4,000 to 6,000 lux. So if you want to see a detailed breakdown of this, you can always change the styles of your illustration, okay, or your of this analysis. So you just select this legend, go to edit styles, and you may choose any of this. But I would prefer this because it's much more clear. Using this option, I think it's much more clear compared to the rest. So just click this. Right, so it display out in detail all the breakdowns of the lux level. Okay, so you can see 6,000, 5,000 to 6,000 at the eastern facade, as well as the southern. But not, yeah, I think this is valid simply because Malaysia is at the northern hemisphere, so you will get a lot of indirect lights from the southern facade, and on the east facade, of course, because this is a morning. This is the time frame is 9 a.m. So of course you will get a lot of lights on the eastern facade. So in this case, if you notice the design, all of the four sides have openings. So you can see that the intensity of light at 9 a.m. is more to this part. Okay. You can also enable sound path. So click sound path on. Okay, so you can see that this is in the actual time frame 9 a.m. 1st of November. So the sun is at this part. So you can basically see during 9 a.m. you will get a lot of lighting coming on at this part. Right? So yeah. And yeah, if you look at the top part, we are more to the northern hemisphere, so that's why we can see the indirect light comes in from the southern side. So I don't know, 6,000 lux. It might give a lot of glaring and so on. So maybe you can try to put in vertical fins or horizontal fins to cut down the amount of light into your design. Right? So this is where you need to strategize lah, according to the data that you have. So let's cut through the ground floor. On the ground floor, we get another reading. Okay, we can see that the light primarily comes in at the southern facade. This is still at 9 a.m., 1st of November. So for the ground floor, you might want to re-strategize. So perhaps this part is the lux value is like below 1,000. So perhaps you might want to provide certain openings to give lightings at this place, or maybe you can place in artificial lights, electrical lights to lighten up this space. So a lot of possibilities. For this space, we don't have any opening, so perhaps you might want to put some openings to allow lights to come in. Okay, so the shape of the window, the sizing of the window, the design of the window plays an important role on how to control the amount of the lighting into your spaces. So in this case, for this model, I am using a very large surface of window. So that's why you see that the lighting is quite intense, even in the morning sun, during the morning time. So this is where you need to, you know, consider to redesign the openings, the window. Maybe you want to add some sun shading. So this is where we want to see how you actually strategize by by proposing certain passive design strategies in order to control the light intensity into your space. Okay, so as you know by now, different spaces require different illuminance level. So in this case, how you design your facade as well as your layout, building layout, in order to control the amount of light into your spaces. Besides that, you can also not just sun path, you can also show shadows as well. Okay, so but before you show shadow, perhaps we look at the sun setting. Make sure it's a single day because this is a single analysis. Okay, this is a 9 a.m. analysis. So it's best that you set your sun according to the same timeline as the analysis. So go to a sun setting and make sure that, okay, this is a single day sun. Make sure that the timeline is within the same as the analysis. So I already changed it. First of November 2020. The time is 9 a.m. There's only one frame. Okay, single day. So just click OK. So let's say if I orientate this, sorry, this is very, I need to adjust this a bit so that it doesn't collide with the sample. Okay. All right, so now all I have to do is just to open the shadow. Okay, so you display out the shadow for during that particular time. So if you notice that this part have a significant amount of sun shadings, but the rest is there's no sunshade at all. So how do you want to limit or reduce the intensity of the light? Maybe you can have louvers, you can have like a coping, a vertical louvers or fins or horizontal fins to cut out the amount of the amount of lighting into your spaces. Okay, so if you notice 6,000 is quite a lot. So there must be something that you need to do for this particular page, for this particular facade. Sorry. Let me cut to the first floor. Yeah, for this part, it's completely shaded on this part, so there's no, but still it's very dark. So in this way, you want to use electrical lighting, it will somehow consume a lot of energy. So what are the best way? So to me, the best way is, of course, you need to create more openings lah at this part. At least a simple window to allow sufficient daylight into the space. Okay, so technically, in general or in brief, this is how we analyze the design lah. So hopefully when you guys do this and apply this into your project one, you'll be able to, analyze it more in detail. And perhaps we can discuss this during the tutorial session as well. Yeah. As for the shadow and sun path analysis, I will also provide a link to some of the videos so that you can see how you can plan out or you can strategize your shadow analysis within the context as well. So I'm going to share it later on at the end of this video. Okay, so hopefully this will guide you. Thank you very much. All right, guys, additional tips for you guys. So let's say if you want to do a rendered analysis, basically to render the lighting condition of your design, You can do it using Revit rendering or A360 renderings. Okay, it's quite easy. So by doing that rendering, you can able to simulate apa ni, the interior of your building in terms of the illuminance level. So these are one of the examples where I have simulate the illuminance level of my first floor. So you can see that these are somehow some kind of a lighting effects that, sorry, the lighting level that I will get into my interior lah. Right, so it's very easy. Okay, so just go to level 1. Maybe you can go to level 1, level 2. You can, this is where you need to capture a perspective view lah. Okay, so select the camera and somehow point your camera to this space, anywhere within your space. Okay, maybe this, for this part we want to analyze the south as well as per facade. So let's look at this part. Okay, so this is the image. Maybe you can extend it so that you can see the whole space. Okay, enlarge the scope box so you can cover the whole space. Okay, I think this should be enough lah. Right, this should be enough. Right, so yeah, this is the shadow. Let's say if you want to view the shadow for a particular time. Okay, go to, next step is you can go to view. This is where you can choose render in cloud. Right, so these are the instructions for conducting Revit rendering in cloud. Okay, so just click OK. All right, so this is the settings that you need to conduct. Okay, so the view I'm using 3D view. This is the view that I just used just now. That I just placed the camera just now. The output type. This is where you can change it to illuminance. So it will show the illuminance level for this particular space. And then image size. I just maintain it as medium. Okay, these are the larger the output, of course, is going to consume a lot of time. So I just make it as medium. Okay, so the analysis is using this time frame. Okay, so yeah, it's up to you. I've set this time frame to 1:18. So it's basically the current time that I'm doing this recording at 1:17. So we're going to see how the light reacts to this space. Okay, and then this one I just maintain as it is. Units, I wanted it to be a lux, and perhaps the range. I just maintain it as automatic, so it will set automatically the range of lux, the minimum and maximum level. So yeah, it requires 1 credit, but if you are using educational license, I think I don't think they're going to charge you, okay, because it's free. So I just click render and give some time for it to process lah. Okay, so once it's uploaded, it can notify you in email lah, or you can just click here, render gallery, click this. So it will direct you to Autodesk A360. So this is where your renderings will be stored. Okay, so not just for the interior. All right, this is the previous renderings that I've did. Okay, so right now I'm rendering the interior. So you can see that there's at this part the lux level is at 8. So this is an afternoon sun. So that's why you don't see a lot of light intensity coming through to the interior space. But you can see lah, on the outer part of the facade, on the perimeter of the facade, this is where the light concentrates during the afternoon. Okay, so perhaps this might lead to certain daylighting strategies. So perhaps on the afternoon, you might need to put certain lightings to further brighten up the space in order to fulfill the recommended illuminance level for this particular space, right? Not just for interior, you can also create plan view. Okay, so this is the plan view, not very nice. Hold on. But this is, I rendered this in very small quality. Okay, so it's not just for interior perspective. You can also place your camera into the plan, same setting like what I did for the energy analysis is now, where you need to place your camera at the elevation and make sure that the camera is perpendicular with the layout, and you can able to generate the same analysis as this. So the benefit of doing this analysis, I think it looks more professional, looks more clear. Uh, yeah, and it gives some kind of a different lah to your analysis as well. Okay, so have fun exploring this. Thank you very much.